Right, I think we'll get going. Well, hello and welcome to this very special event with Girls on Track UK. And of course, as always, these special events are only made possible by Motorsport UK as well. So my huge thanks to them for making this evening's webinar possible. My name is Rosanna Tennant and I'm a sports broadcast journalist, and I'm going to be hosting this evening's webinar. And I am very excited to meet this evening's guests, but I'm going to keep their names a little secret for a little while longer, just while we run through some housekeeping this evening. Now, you might be able to see that we are recording this evening's webinar, which means that if you feel like going and having some food, or you need to put the children to bed, or you need to do some homework, then feel free to nip off and do that, and you can watch the recording of the webinar a little later on Girls on Track UK's Facebook community page. Also, unfortunately, as much as we love to have you all able to speak tonight, we are going to mute everybody, and unfortunately you're unable to unmute yourself during the webinar. I think it just makes for an easier listen, and it means we can hear our wonderful guest speakers and all that they have to say about aerodynamics. There's the key word for this evening. Also, we would love you to send in some questions. I know people have sent questions in to Girls on Track UK already, but do feel free to use the Q&A function. We'll be monitoring that. I'll be monitoring it as well, and I will be able to put your questions to our speakers this evening. Now, it is time to introduce them. First and foremost, I'm going to introduce Willem Towett, 35 years of experience in F1, all in aerodynamics, across a range of Formula One teams. So I cannot wait to talk to Willem tonight and to hear all of his stories and all of his intelligence and knowledge and expertise about aerodynamics. It's something that I still struggle to grasp. So tonight, Willem, it is all down to you to let me know and let all of us know a little bit more about this wonderful subject. Also joining us tonight is Catherine Richards, wind tunnel technician at Mercedes-AMG Petronas Formula One team. And you've been with the team almost 16 years. I can't believe it, Catherine. So you've lived and breathed the team all through its different iterations. So again, I can't wait to talk to you a little bit about your journey in Formula One, aerodynamics, and of course, motorsport more generally. So there we go. Those are the introductions. I'm going to start then with you, Willem. If you could just tell us a little bit about your role as things stand, and perhaps a brief summary of what you've been up to over the course of those incredible 35 years. A very good evening to you.
Thank you. So I started in lower forms of motorsport, and in fact my degree was actually in biochemistry and genetics when I started. So I started in a completely different area, but just fell into aerodynamics and just became fascinated with, it's actually quite a complex subject, and became fascinated, played with some cars in Australia on aerodynamics, and ended up getting a job in England working on sports cars, and eventually got myself a job in Formula One, and have sort of been in that area ever since. Started in a very small aerodynamics team. It was a team of one person, made it two. My first role wasn't an aerodynamicist. I was a model maker, making parts other people designed. And then you grow within the team, and that's what I did, and learn. And so, yeah, ended up running the aerodynamics teams for Benetton, Ferrari, Honda, most of the team for, and then Sauber and BMW Sauber. So had a lot of fun, really a lot of fun. And during that time, I've been able to bring into the sport a lot of young people. Catherine was one, and one of the first people really that I mentored. And so I've really enjoyed, especially as I've got older, I've really enjoyed passing the baton, if you like, to the next generations of people coming along. And that's what really gives me a buzz today. Find someone with raw ability and help them to realize that ability. And so now I don't work anymore in Formula One. I find, if you like, customers for the capabilities of the Sauber group, which includes the Alpha Formula One team.
Fantastic. Some huge name drops there, Willem. I'm just like, whoa, Formula One team after Formula One team. And apologies for the fire engine that went past at that point as well when you were explaining everything. So if you heard that, apologies. How wonderful. What an amazing summary. And Catherine, then tell us a little bit about your role, because I've been lucky enough to see you in action in the factory at Brackley with the Mercedes-AMG Petronas Formula One team, but I never really know what you're doing because it's all so complex. So tell us a little bit more about your role.
Well, my primary role is to run the wind tunnel facility that we have at Mercedes, so that the aerodynamicists who sit on the other side of the room can put performance on the race car, and so that we can go to the track and win. My responsibilities are mostly to run the tunnel, to make sure it's working properly, all the data's coming through, it's behaving itself, it's doing what I expect it to do. But I've got other roles. I do diagnostics, write procedures, there's lots of maintenance involved, lots of cleaning, everything. And I actually even work on the model as well sometimes when it's all hands on deck and we've got big changes.
Fantastic. And it's always top secret. Whenever we're filming in there, everything has to be sort of, it's all classified, isn't it? So you've made sure that what we can film is available to the wider public, and everything else is top secret. So I love coming into the wind tunnel when you guys are working. So now we know what both of you do. I would like to know a little bit more, I think everyone would, about aerodynamics. And actually, when I was talking to Pat Simmons, F1's Chief Technical Officer, yesterday, and I asked him that question, you know, what is aerodynamics and how does it really affect us at home? So I wondered if you could expand a little on the subject, talk us through aerodynamics and perhaps where we might find it in our everyday lives and how it works in F1.
Okay, so to be able to explain, I'd like to share my screen, which I'll try and do now. Take a few seconds.
All right, go for it. This is the beauty of Zoom.
Yes.
We can share everything and see all this wonderful experience, expertise, and knowledge. Here we go.
So, okay. So aerodynamics in motorsport is really the key driver for performance. It's either the aerodynamics or the powertrain. If you got one of those wrong, then you're really in quite serious trouble. And say aerodynamics makes about 25 seconds a lap, or maybe a bit more than that, with today's Formula One car. So if you made the car, let's say, aerodynamically neutral like a road car, you'd be going roughly 25 seconds a lap slower. Really incredible power that aerodynamics adds to Formula One, but it's used in many areas. Move mouse, Willem. I'll go back. So here are some pictures to show aerodynamic research. This happens to be Sauber, but you don't need to know that it's Sauber. For example, a full-scale car can be put into a wind tunnel and run, depending upon the facility, at almost any speed you like. At Sauber, we can go about 290 kilometers an hour. You can put models in the tunnel. The construction of the models is really incredible as well. You can put normal road cars in the wind tunnel. And we also do computer simulation of airflow that allows you to visualize airflow in lots of different ways that helps aerodynamicists to understand what's happening. And it doesn't have to be air, it can also be liquids, for example. And it doesn't have to be a race car, it can be air circulating inside an oven. You can work out not just the air circulation, but also the temperature distribution inside an oven. And all that sort of work is done. That's real aerodynamics work. Now, here are a few of the cars that I've designed or worked on in my lifetime. If I did one for every year, and in Formula One it's one for every year, there's an awful lot of cars there, and I've been in the game a very long time. I've also designed and worked on a great number of facilities. And for example, the Mercedes facility that Kate runs, that also is one of the ones that I specified and got running or got produced. So, and it's not that I wanted to design wind tunnels, but there you go. In the end, if you can't get what you want, you have to design it and build it. And I'm also a crazy person outside work, but you don't need to see that. Now, we get to the real work now, aerodynamics. Aerodynamics has a lot of power, and one of the easiest ways to demonstrate it is I took here a Formula One wheel. They're quite small.
Willem, what are you doing there?
Yeah, I'm being a stuntman. Connected it to a vacuum cleaner. Now, a vacuum cleaner does not create a full vacuum. It creates a very partial vacuum. It's about, a good one might be 15% of a vacuum, maybe even 20% of a vacuum. And this is a fairly old, well-used university vacuum cleaner. And you connect. So effectively, what you have is on the outside of the wheel, you have normal atmospheric pressure. Inside, because I've connected it to the vacuum cleaner, you have slightly lower pressure created by the vacuum cleaner. Now this is a 13-inch diameter wheel, so 12 inches internal diameter that is exposed to the upper surface, and that's enough to lift me. A Formula One car will generate lower pressures than this, the pressure I have inside the wheel, in other words, the pressure inside the tube of a vacuum cleaner. Formula One cars will generate lower pressure than that on most or a lot of the underside, on the underside of wings, front wing, rear wing, and the floor in particular, near the kick line of the diffuser, near the leading edge where they have all those little vortex generators. So that's why, and that's how a Formula One car generates, if you like, so much tons literally of downforce. Now, air is made up of molecules. They're all around us, and they are really small. There are about, roughly, going too fast here, they're about 2.7 million in 10 centimeters, and if you add up the amount in, say, a cubic centimeter, it's nearly 30 million. I'm not going to use the long words, but anyway, it's a lot of molecules, and mostly we think of air as a continuum, but actually it's made up of molecules, and molecules have a certain size and they behave in a certain way, and there's actually quite big gaps between them. Now, one of the laws we talk about in aerodynamics is the square law for how forces increase with increases in speed. So when you move your hand through the air initially low speed, then you don't feel there's really any resistance at all. But if you go twice as fast, we expect that you're going to feel roughly 4 times the force. And this is how I try to explain it. If you go twice as fast, you're going to interact with twice as many molecules. But as well, every interaction with an individual molecule is going to exchange in the direction you're moving roughly twice the force. So you have a multiplication of 2 because the number of molecules you're hitting, and a multiplication as 2 as well because each interaction exchanges twice the force. So that's where the square law, 2 times 2 equals 4, you go twice as fast, 4 times the force. That's where that comes from. So that part of it, I think, is reasonably simple. Now, a lot of molecules.
My brain is exploding in all sorts of different areas. Lots of molecules.
Well, there is a lot. Explosion will follow. That's coming in a few minutes.
Okay, yeah.
I think aerodynamics is really fascinating. Now, it is really complex, and you need a lot of mathematics to work in it, let's say professionally. But to understand some of the concepts, I think it's really important at first to understand a few concepts. Now, even though you have millions of molecules in every centimeter, there's actually big voids between the molecules, and a molecule will move about 200 to 260, it depends on all sorts of things, but it'll move about 200 diameters before it interacts with another molecule. So there's a lot going on there. And this motion, so the molecules move around at a bit more than the speed of sound. And the speed of sound is actually inside my voice box. I vibrate my larynx, and that interacts with the molecules. Now, the molecules, if we're standing in the room, the molecules I move, you don't see. They don't get that far, but a wave goes through the air, and that wave is what hits your ear and you hear. So sound is also aerodynamics. And this was first figured out, the first hint people had was Robert Brown, a botanist. He looked at pollen particles, tiny pollen particles, jiggling around in water. And he tried to understand, he described this motion, this random motion that the pollen particles had. And it was then Albert Einstein who was the first to propose an explanation, which is that the pollen particles are being moved around by, in this case, it was water molecules, but it can be the same in air. And the speed of sound is just the speed of the interaction of the molecules. So in air, where you have big distance between molecules, the speed of sound is really fast, yeah. But in water, the speed of sound is actually faster. So if you want to send a signal and you happen to be on a boat, you're better to send the signal from underwater and ping across like a submarine does. That's going to travel faster than sending a message through the air. And then, okay, the speed of light, which is what we use electronically, that's even faster. That's another story. Now, I do a little experiment where I show, let's say, to try to demonstrate the sheer power and the sheer speed of this Brownian motion that we call it, of the molecules moving around. So I take a tube, the inside diameter is almost exactly the outside diameter of a ping pong ball. I take a ping pong ball, I just touch it to a piece of tape, put tape over one end, and I put enough excess tape there that I can rip it off with my hand. Then on the exit end, I just tape over blank, and then we connect a vacuum line to the far end of the exit end, let's say, of the pipe, and let the vacuum pump work away. It takes time. There's a vacuum pump you might use for composite manufacture. And then I come along and I rip the tape off. Now, the first few times we did this is a high-speed video, and you don't see the tape come off the far end. You just see pieces of ping pong ball that have hit themselves against the blue chest on the far end of the workshop. This is in the workshop at the University of Bolton. And once I got lucky that I'd cut the tape square, and that slowed the ball down. I'll stop it there because it goes on and on. Yeah. So that for me is a real little bit of fun. Now, there's something else I'd like to talk about, is that when air passes over a stationary body, we grow what is called a boundary layer. And the boundary layer, we have a rule in aerodynamics that says the air that's in contact with the surface is effectively stationary. And that's something that took me a long time to get my head around when I was learning aerodynamics, because if you make the surface super smooth, why would the air be stationary? And it's actually the molecules that make up the smoothest surface on the planet. No matter how smooth you get it, it's still going to be made up of molecules or atoms. They're going to be of a similar size. They might be a bit bigger, but they're going to be of a similar size to the size of molecules in air. And this is an image of a sheet. It's actually a sheet of graphene that's as smooth as mankind can make it. But now you're looking at an atomic scale. Now, unfortunately, they've zoomed in on the height axis. So I've taken the rough size of an oxygen molecule, and that's this little green blob in the bottom. And that's about the size now. And a molecule would be round, roughly. But that's about the sort of size. And you could imagine if you're moving air in one direction over this surface, the molecules that hit this effectively mountain range are going to be, many of them are going to be bounced backwards, but effectively you're going to be stopping the air that contacts that surface on average. Yeah. And then you grow, this becomes a layer that grows, that changes aerodynamics. And a boundary layer can be changed quite a lot by what it interacts with. I need to stop in a minute, but I say maybe this is the last. I'll stop here. And on the top left, we have an old Formula One car. We can't show current ones, but a very old Formula One car, an instantaneous look at airflow around that car. And we're looking, the shapes are the vorticity, the rotation of flow. And the color is how much energy is in the air. So computational tools, computer simulation of this airflow can give you absolutely amazing imagery that is scientific information. It's useful information. And barnacles on a whale's tail or fin, they act to create turbulence in the air, which actually helps the flow to stay attached to the fin, and it gives the whale the ability to swim faster. Really incredible. And then a bluff body like a truck, you can see the air is quite disturbed around a truck. If you ever stand on the side of a motorway when a truck goes by, or me, I learned about turbulence behind a truck by riding a motorbike, trying to overtake them, or sitting in traffic looking to overtake them. You get quite a lot of buffeting. Yeah. So I'm going to stop there because otherwise I can go forever. But we need to answer for a few questions, I think, and Kate has to have a go.
That was fantastic. Thank you so much. So interesting. And that last bit about the whales, I didn't know that. So thank you very much. Fantastic to hear all of that and creep a little closer to understanding aerodynamics. Now, I can see no questions have been asked yet. So please do feel free to pop a question in the Q&A function. You'll find it at the bottom of the screen. But some of you have already sent in some questions, so I'm going to put some questions to our wonderful speakers. And Catherine, first of all, I just would like to know why you wanted to go into aerodynamics and that side of motorsport. And I'd like to know it, but also one of our wonderful viewers has also asked that question.
That's kind of a bit of a long story, because when I was at school, I actually wanted to be an airline pilot. That's what I really wanted to do. My auntie took me to Heathrow and I was like, yes, I want to fly aeroplanes. So I did all my schooling so I could go to flying school when I left school. But one, I wasn't tall enough, and two, I wasn't old enough. So I went off to college just to do a 2-year course, H&D in Aerospace Studies. At the same point, I'd started to watch Formula One, was getting interested. Michael Schumacher came on the scene, thought, you know, he's quite good. And I was just starting to learn about aerodynamics as well. So I thought, one, I wanted to go on a factory tour, so I wrote to Benton. And a very strange man replied to me, Willem, come along, bring a guest. So I took my mum. We went for a factory tour, and then I asked about, you know, whether the wind tunnel was there. And the woman said it wasn't, but it was in Farnborough. I was studying Farnborough. To cut a long story short, I ended up going to the wind tunnel about 6 months later. And once I realised that a Formula One car went to wind tunnel, I was like, forget flying, it's not happening now. And I just carried on with that aim. I mean, I originally wanted to be an aerodynamicist, but the more I got into wind tunnels, the more I loved them. And I just pursued wanting to go and do that.
Well, that sounds a very easy hop, skip and a jump, and suddenly you're working for a 7-time world championship winning Formula One team. But how did you then make it a reality to actually get the job that you do now? You know, how many different jobs have you had to do, and then learning and building all of your expertise?
So I did my H&D in Aerospace Studies, and I converted that into a degree in aerospace engineering. Then I investigated going into Formula One then, but was told to go and get more experience. And I applied to go and do a PhD in vehicle aerodynamics and got it, which I was quite amazed at. So I went and did some research, and that was wind tunnels again. And then some life circumstances meant that I went actually to Germany for 3.5 years and did some environmental aerodynamics.
What does that mean?
Wind flow around buildings, in which time they started building the tunnel at, which was Honda then. And as I was coming to the end of my time in Germany, Willem was saying, we need wind tunnel test technicians, you know, when are you coming back? So when I got back to England, and I couldn't drive then, so I went to Banbury Station, and my then, who was going to be my boss, Jeff Parker, picked me up. We were driving to Brackley, jabbering away, and he said, well, interview. And I looked at him and went, no one told me this was an interview. I thought it was just a little chat. Turned out to be an interview.
Oh my goodness, what did they ask you?
I actually can't remember.
She's shy. Can I step in? She's shy. No. So if she'd been warned, she'd have been worried. So no warning, much better.
That's a very good tactic. I like it. Oh my goodness, that's brilliant.
2 days later, Willem rang me, got the job, started 2 weeks later, and that's it. I've been there nearly 16 years.
How amazing. And Willem, how fantastic, you know, replying to people. We were talking shortly before the webinar started about how you always reply to people. So what's the best way for people and students who are watching this evening who might think, actually, this sounds like something I'm interested in? Should they just send an email? What do they need to have on their CV?
So I would say do your own research, but so I use LinkedIn. So LinkedIn is the best way to connect with me. It may take me some time to reply to questions because I literally get, at least on a really low day, I might get a dozen questions on a really low day, and I have a full-time job and then some.
Yes.
So it does take some time. My wife is fantastic and she understands. You can imagine we've been together a long time and she knows aerodynamics really very well. I don't think she'd want to teach it, but I would imagine she might be able to.
Did she put the slides together?
Well, she checks them and corrects all my bad spelling because I'm a terrible speller. Yeah, so she checks them, and she does help me a lot with my presentations. Yes. Fantastic.
So, and I guess, Catherine, just a reminder on what you studied, just in case people didn't note that down.
So I did a degree in aerospace engineering, And then I went on to do a PhD looking at vehicle aerodynamics and pollution dispersion.
Wow. Okay. I'll make a note of that for my next life. So then if people are already sort of on their way to studies, you know, they're already in maybe A levels, or they're already thinking about what to go for university, and they've chosen something and they think, oh gosh, but is that going to transfer? Is that possible? Can you do one type of engineering and then cross over into aerodynamics? They're not going to sort of put your CV into the bin because it doesn't have aerodynamics written on it from university or college or school. And maybe,
Catherine, do you want to have a go, or would you like me to?
I just through the experience of who we've got in, even just in the wind tunnel group, all different backgrounds. So you really don't need to have either a degree, PhD, even a background in aerospace engineering. I mean, my shift colleague at the moment, he worked at Ricardo on the dyno with the engine dyno. A chap we had who's retired now, he was in the RAF before he joined us. So really I could not have learned my job. I could not have been, you know, I couldn't have learned it from any book or from any course. But it's about being open to learning and being able to adapt. And if you've got basic background knowledge in just stuff and you're enthusiastic and you can work in a team, it's possible. It really is possible.
Well, I've got one question here that I think probably a lot of people are wondering, you know, if I work in aerodynamics, do I get to go trackside? Because you mentioned a lot about the wind tunnels, and we saw the wonderful pictures there from you, Willem. And, you know, I've been to the factories and I've seen the wind tunnels. I'm sure a lot of people watching may have had a lovely factory tour, a bit like you did, Catherine, but that's not at the track. And if you're a real F1 fan and you want to work on an F1 car, you want to see it race in anger, are you going to be able to do that if you're an aerodynamicist? And maybe, Catherine, you could explain what the sort of current state of play is on that.
You can. We have a trackside group, and there are aerodynamicists in that trackside group. And they also liaise with the tunnel group as well. And we have aeros that go to the track. And she's actually a lady, Kimberly, and she's responsible for the aerodynamics of the car at the track. So yes, it does transfer. And if you want to go trackside, it is more than possible.
And you're talking about Kimberly Stevens, I think that's right.
Kimberly.
Yes, I'm sure a lot of people watching may or may not have seen Kim at track. And obviously she wears the most wonderful cowboy boots when we go to Austin, because she is American. So it's super cool when she heads out stateside. And just a little bit more information about what then aerodynamicists do at track, because without a wind tunnel, I sort of feel like, how are you running all your simulations? What are they doing at track? Where's their little sort of office or room or lab like that?
Willem, you want to answer?
Yep, sure. So that Kate doesn't give away exactly what Mercedes do.
There we go.
What our team does is less important, yeah. So, but it's the same in the end. So a track aerodynamicist will be a police person making sure that the right things are on the car, checking the state of them. Are they being kept clean? Are they damaged? Then that person will also monitor during any live event. They'll be monitoring the two cars, looking at aerodynamic balance of the cars, and looking in the end for any damage to the aerodynamics. So we push the airflow to the limit in Formula One, and then the drivers push their ability to drive to the limit. They may have accidents, and if you have an accident, so quite often you'll lose part of your front wing end plate, or you might get a little bit of side damage with a wheel coming into the barge board area, which is between the two wheels. Then the track aerodynamicist will be monitoring and assessing that. So there's enough sensors on the cars to be able to get a good idea of how much downforce the cars are generating and what the balance of the car is like. So let's say you lose some parts from the front wing, there's a good chance then that the car will have less front downforce. Then the driver will complain that I'm getting understeer, the car's not turning in, the front end doesn't have as much grip. If you have damage in other places, you may get oversteer, so the car's harder to drive, that the tail end is sliding. So the track aerodynamicist or aerodynamicists, they are part of the track group and they travel regularly. But also at times when the team can take one or two people just occasionally to the track, and I would be one of those, would have been one of those in the past, then you can go as a member of the aerodynamics group, you can go just to say one event a year, might be a test, might be a race meeting. And then your job there is really to observe how the team is working, but also to look at the aerodynamics of all the other cars. Yeah, you don't win
Like a
by
spy.
copying. Exactly. You don't win by copying, but you would be daft to ignore the millions spent by other teams. Yeah.
Absolutely.
And it's really millions. So I've been in charge of budgets of the order of £10 million for just doing the aerodynamics.
Well, that's fantastic. I mean, we saw that little bit of, I mean, we've seen lots of bits of car fall off, but Valtteri Bottas, for example, that little bit that came off in Paul Ricard, I mean, your team must have been poring over what was going on there, and I'm sure he was relaying to the team that something felt wrong. And of course, we then hear the likes of Ron Meadows, your sporting director at Mercedes, but then the likes of Jonathan Wheatley at Red Bull on the phone to Michael Massey saying, we need that bit of carbon fibre back, because I imagine it's all useful for you to then work out what to do next and how to improve.
Yeah,
Yes.
mainly that another team doesn't get hold of it.
Yes, exactly. Or Sam Collins, my colleague, who's
Yes.
one of the tech
He's
analysts
fantastic.
at F1. He takes bits of car home with him. I'm like, you can't take those bits. You can't take those bits. We had a great question in from Ellie Finnegan. Thank you so much. Questions starting to come in now, so don't be shy. Ellie Finnegan saying, what's your opinion on the 2022 regulations reducing aerodynamics? And on that, also, the time in the wind tunnel, we know that that's going to be a sort of sliding scale now, according to who does well in the championship from one year to the next. And Catherine, perhaps I ask you this. People might be thinking, well, there's not going to be as much need of aerodynamicists now because certain teams aren't going to need them. So are Mercedes going to be losing people from their wind tunnel team? Perhaps you could tell us a little bit without telling us too much.
I don't know how much I can say, really. It's going to be a challenge, so we need everyone. I think that's all I can say. It's a challenge.
So keep applying to those top teams, even if that's your aspiration to go for top teams. Don't worry that the time's going to get less. They'll still need help.
We still need. They've ripped up the rule book. We're starting from scratch. So yeah, it's a challenge. So it's all hands on deck at the moment.
Yeah.
What did you make of the new car? Obviously, it was launched this afternoon. It is cool though, because from a very layman's point of view, there are lots of bits on the car that you can really see now with the sort of over the wheel bodywork, the front wing with that curvature, the rear wing looking very different. Is it a case of seeing that car, you'll be given plans, I assume, from the F1 team to sort of an FIA to then go and work on? Is that what they're going to do for you?
Yep. So the rules for 2022 have been researched by Formula One management in collaboration with the FIA. And the research started some years ago. And the background behind the regulations is that the wake of a Formula One car, the dirty air behind a Formula One car, stays quite wide and low at the moment, or a part of it. So the rear wing will take a big chunk of air and will draw it upwards and away from the cars, really just flies above the cars following. But the wake from the wheels in particular and other parts, the floor of the car, tends to spread out and stay low. And that's why you can't follow close in a corner. It also gives you a benefit of having some additional speed when you're following another car on a straight, but you can't get close before the straight. So you can't take full advantage. And the cars now, the rules that this new research has created, if you like, that those rules are aimed at taking more of the wake up and above the cars that follow, and to have a much cleaner airflow behind each car, so that you can follow more closely in the corners. You'll actually have less of a drag reduction when you're following on the straights, but you'll be able to start closer. That is the objective of the regulations. And now the rules have been written, and the teams will now have well and truly started work, and they are evolving those cars for next year. And I'll be fascinated to see what they look like.
Yeah, it's going to be fantastic. And also what I'm hearing really there is that there's going to be plenty of opportunities for students and graduates to really embed themselves in teams, not just the F1 teams, but also the FIA and Formula One, because they've all got departments now looking at this new car and how we're going to race it. Got a great question in from Gori Moharia. A lot of companies require experience to get the job, but if you've just come out of A-levels, what type of experience would they be expecting or looking for, if any? And it's that catch-22, isn't it? You don't have experience, people need you to have experience, and you can't get experience because you've got no experience. So Catherine, what would you advise?
I would advise try and get work experience placements in places. So, you know, during your schooling and if you're going on to further education, write to universities, write to the teams, see if you can go or do a week's work experience. It doesn't have to be Formula One teams, you know. Experiencing any kind of motorsport is good, but also experience in any kind of engineering is good as well, because it shows that you've got some discipline and, you know, you've got the willingness to learn. Because, you know, even if it's just manufacturing or, you know, an electronics company, all of that kind of background and that experience is really, really useful for when you move on. So any kind of experience at a young age is valuable.
Yeah, I agree completely.
Fantastic.
And so as an example of an experience that's nothing to do, if you like, with motorsport, when I was going to school, we were a very poor family. I was mowing lawns to earn money. Then the lawnmower breaks down, you tinker with it and fix it, and you ask questions. And when I was going to university, one of my jobs was pumping petrol at a garage on night shift, because I was studying during the day. So the only time I could earn money would be either weekends or night shift. So I did night shift 3 days a week, Thursday, Friday, Saturday. Fridays were hard at lectures, but anyway, so night shift working at a garage, effectively pumping petrol. But cars come in, and especially in those days, they would break down, and then I would wait until the mechanics came in the morning and ask, well, what's wrong with this car? Why couldn't I fix it? And that general knowledge helped me have a broader picture of cars and how they worked and so on. So sometimes the strangest work experience can be directly beneficial and useful. It can be anything. And it doesn't have to be a motorsport team. It can be a supplier, a tire supplier, a parts supplier, anything that gives you human contacts, because human contacts in the end are really valuable, and also just general knowledge and experience that gives you a way in, a knowledge base that most people may not have, or details that people may not have. Yeah.
No, you're totally right. You almost need to take a step back from the wind tunnel and aerodynamics and think how many people, how many teams, how many organizations are involved in this wonderful thing and this automotive industry and motorsport, and sort of, as you say, just pick little areas that you could get your experience in. Kate Amos has just picked up on the sort of comments we were making about the rule changes and says, as well as the teams, do the FIA also have a large team in aerodynamics? Because perhaps people don't realize that the FIA have a lot of engineers obviously working within their organization.
They do. There's actually more people working, if you like, in the field of aerodynamics. So the FIA have some real experts working in aerodynamics, writing regulations, and then working together with Formula One management. And Formula One management, because they're the ones who have the money, they are doing more of the actual, if you like, on the ground research into future regulations, specifically for Formula One. And they have a decent sized team. It's not as big as a team working in Formula One. Honestly, in my opinion, it should be as big as an aerodynamics team in Formula One, because they're writing the rules, and you don't want a small group writing the rules and a huge group finding a way around them. That's not what you want. You want a set of regulations that are going to do what the rule makers need, which is close, fair racing and small differences between the top team and the bottom team.
Well, let's hope somebody from HR and F1 is watching this, Willem, and they can get more people into the FIA and the F1 steering groups.
Well, the teams will vote against that, because the teams want more people and more money.
Exactly.
Yeah, but I think actually the fairest balance is that group of people needs to be as big as a team's worth of aerodynamic people.
Well, again, all I'm hearing is more job opportunities, hopefully, in the near future in F1, FIA, motorsport more generally. A couple of questions coming in about non-UK students and people who obviously aren't based in the United Kingdom or even Europe. Maisie's asked, you mentioned knowing an aerodynamicist from the US, obviously we're talking about Kim. What advice would you give young American engineers who are interested in pursuing careers in F1, given the high concentration of teams and operations based in Europe? Obviously F1 is very Eurocentric, obviously with a push to go more to America, with Miami obviously now announced. But there's IndyCar, there are a lot of other wonderful motorsports out there, NASCAR, you can get into the trucks. I mean, there's a lot going on in America, obviously more than worth getting involved with those championships, I would imagine, because aerodynamics still counts for a lot out there. And then you can come to England or to Europe and say, hey, look, I'm really passionate about F1. How about a transfer?
Kate, do you want to have a go?
Yeah, well, yeah, but we actually have a young lady. She was with us in the tunnel Monday, Tuesday, an aerodynamicist, Hillary. She is from Canada. She's not long graduated. She's in her sort of early 20s, and she literally just applied overseas. She applied to a position, and then she literally just picked her life up and moved to the UK. She just took that punt.
Yep.
So
I think obviously taking the punt is the first and foremost thing you got to do. You got to send that email, you got to apply on LinkedIn or through whichever job site you're using. And a lot of the teams obviously post things on jobs boards. But I suppose a lot of people, there's that huge, you've mentioned you move your whole life, but also the visa element, will you be sponsored, all those sort of things. I imagine that's just a question for the HR departments of the Formula One teams. And if they want you, obviously they'll work a way around how to get you in and work with you to make that possible.
So I would say it is clearly harder for people who are not UK based. You're not right there to go for an interview, and you have the potential visa issues. They're real issues. But if you look at the sheer number of non-English or non-UK people in UK teams, there's a lot of them.
There is a lot.
I'm one. I have an Aussie passport. Yeah. Okay, I have an English one as well now because I married Sue. But I made a start with just an Aussie passport, and you have to figure out ways, ask a lot of questions, show what you've done that you are worth letting people in. Now I got in on a working holiday permit, so below a certain age you can come in on a working holiday. That's what I did.
Basically, get in touch, and you're already on the right sort of journey, as it were. I'm going to move on to a question that, I mean, my poor little brain is hurting reading this, just trying to work out what it is. But Yannick, or Janik, I'm so sorry if I pronounced that wrong. Do you think it's more important to understand CFD at an algorithm level, e.g. programming own solvers, or master commercial software when working in Formula Student as preparation for a career?
Cool question.
You can answer that one, Willem.
I was going to say I can answer it. I was like, no.
That's a great question. I'd say you, Yannick, you've already made a big step in the right direction. So I would say when you're first learning, you're probably better to just work out how to use commercial software. Trying to understand the mathematics behind the software means you need a really high level of mathematics, but I think it does depend on what really turns you on, if you like, in engineering, in an engineering sense. There are plenty of people I know who adore the mathematics of aerodynamics, which is highly complex, and so for them, getting into open foam is a very good quality CFD code, computational fluid dynamic code, but it's open source, and therefore you can read the many tens of thousands of lines of code. If you're into that sort of thing, you can understand more about what the strengths and limitations are of the code without anyone having to tell you. But it takes a huge amount of time. So for most people, it's definitely going to be better to use a code that already exists and build on that and actually work on the aerodynamics. And at first, you just have to trust that the answers are good. One of the things that is quite a challenge with computational fluid dynamics, with CFD simulations, is there are limits to the quality of the mathematics that are, let's say, solvable on a normal computer. On a laptop, I'm working here on a laptop to talk. On a laptop, there is none. There are no laptops good enough for even Formula Student. You won't get the right answers, but you may get pointers that send you in the right direction. And then you have to build something, put it on the track, and see what it does. Yeah, and I think
that's my Friday evening sorted, Willem. I'm going to start learning all about that. I've got another question in then from Vaishnavi. Is a specialised master's degree in aerodynamics better, or a master's in motorsports engineering? Catherine, you're looking like you've got an answer.
It depends on which branch you really want to go into. If you want to do the mechanical side, VDG, the actual design part of the car, then yes, the motorsport engineering. But if you want to go more into aerodynamics and CFD, then the other option is better.
Yeah,
and then
I concur.
Perfect, amazing, that's awesome. If we then go slightly further back in studying and academic kind of a journeying, Ivana has asked what subjects are the most relevant to the study of aerodynamics or a career in aerodynamics. So if people who are watching are choosing GCSEs or A-levels, obviously maybe pushing more towards the STEM subjects, I would imagine.
Yes, definitely. Maths, physics. Maths and physics are the key ones.
I'm quite interested because I think we've done, a webinar, Catherine, maybe you ran it, I think. Maybe it was InWed. We were talking to somebody who'd done art. And I was fascinated that somebody in a Formula One team was really using art. And I think it might not have been an aerodynamics, but it's just interesting to think that if you still have a real passion for art or something that's not in the STEM kind of world, it's worth adding that to the mix.
Yes, because being an aerodynamicist and a designer, you've got to be creative anyway. You're a creative person. So yeah, art it's a good one, definitely a good one.
So that's an area where I feel it took me a lifetime to learn how important the look of a car is, the aesthetics of a car, because in the end, even a Formula One car, it's an advertising medium. It's got to look let's say, in some way, in someone's eyes, it's got to look attractive. And the first person to say that to me that I remember of was Ross Brawn, and I thought, what an idiot! Why does he care about what the car
he
looks
could go
like?
anywhere.
It's got to win, then it's beautiful. But actually, he was right that the car has to also look good. And we do learn in the end that if the car looks good, you've got a better chance of it also working in a better way functionally.
Yeah, a good looking car is often a fast car.
Yeah, the form and function do go together. Took me a long time to learn.
So art is a useful one for the aesthetics. Scarlett has messaged saying thank you for such an interesting presentation, and I concur on that one because I'm not doing the presenting here, I'm merely facilitating. I would love to know what attributes and qualities, etc., that you look for in a junior aerodynamicist just starting their career and looking to forward it, sort of take it on a bit more. So yeah, in terms of character, so we might be able to tick off all of the sort of academic qualities, but I imagine team player, it's often a phrase we use a lot in Formula One. I think people see the two drivers and forget that that's just the tip of the iceberg. So Catherine, I imagine working well as a team would be a good starting point.
Yeah, the important one for us is that obviously, because we are the tunnel tech, we sit on one side of the room and the aerodynamicists sit on the other side. So you've got to be able to communicate. You've got to be human. You know, you need to be a human being and not just a maths machine. And just be able to work well. I mean, we have so many aerodynamicists and they're all different, and we all have a different relationship with every single one of them, depending on who they are. But you just need to be able to, work as a team and just be open to suggestion and even criticism sometimes, because they're not always right and we're not always right. And it's all about working together. And being able to play on each other's strengths as well. So, you know, so it's not about always being, you know, the best mathematician, the best aerodynamicist. Actually, you need to be a good human being that can work with you, can organise, and can, you know, sort of see ahead what's going on, you know, what we're doing for the rest of the day, and think ahead, because it just works so much better.
Definitely, especially when you're getting human input from the drivers, you need to be able to process that rather than just always the facts and the figures, I imagine, as well. And I just want to pick up on, obviously this is Girls on Track UK, and we're so lucky to have Willem joining us this evening, and so I've got a 50-50 split with my guest speakers. Catherine, you've mentioned Kim, well, we've mentioned Kim, you mentioned Hillary, so and then Catherine. So that's, I'm counting 3 already in the aerodynamics team and world at Brackley. Pretty good spread of male and female in the team, and should girls be a little bit worried?
Still not. There's still not enough. I mean, although funny you should say it, because this week, so we had Hillary Monday and Tuesday, and then yesterday and today, and I think she might be listening in, we had Susanna, who's from Poland, and she was our aerodynamist. She's a graduate aerodynamist. So we have had female aerodynamists all this week.
Starting to sound like a beautiful South song. Probably not right for the age group, but I'm loving it. I'm loving it.
But there aren't as many as there should be. I mean, there's more in the aerodynamics department. We've got a few more aerodynamicists now. There are some young ladies in the main factory in the different departments. I still don't know of another wind tunnel technician in Formula One yet. If there's one out there, I don't know. But there is still room for a lot more females in the sport, most definitely.
Well, that is great.
I would say there's no reason to be scared as such, but the balance is definitely wrong. It struck me as being stupid from when I first started working in Formula One, that why would all the good engineering brains be in male bodies? That's not actually the case.
Right.
There's going to be a 50-50 split of the best engineering brains in the business. If you want the best brains, you need a better balance. And the other thing that I've learned trying to build as a head of aerodynamics with a lot of people in a department, up to nearly 100 people, they're bigger. Mercedes is bigger than that, but big groups of people. I found a lot of improvement, let's say, in the attitude of my group. If you created more of a family feeling, and to have a family feeling, you need diversity. You need men, women. You need people from different, if you like, cultural backgrounds. You need a mix. It helps when you're solving really complex problems, and they are all problems that are at the limit of our mental abilities. You need that willingness to compromise for one another and work together. And you need people with different skill sets, so you don't have all people from the same university having done the same degree, taught by the same professors. That's nuts. You need a varied background, so and also a varied background of work experience. A bit of America's Cup yacht, a bit of aerospace, a bit of aircraft, a bit of normal automotive, all sorts of different areas that use aerodynamics to bring in different knowledge bases.
Definitely.
And a family feeling.
What I think also is important to stress is, I'm sure since the beginning of your career, Willem, a lot more women are now applying to work in the motorsport and the automotive industry. And I think it's probably very important to state that I don't think these organizations are putting female applications to the side, in the bin, to the bottom of the pile. I don't think that's that. I think what we really need is for everyone watching today to think, yes, I'm going to apply, because I think we need more applicants, because there is interest now, and it's not a case of their CVs not being looked at. It's more that we need more of their CVs to be sent in the first place. So yes, if you're watching and you're thinking this could be something you're interested in, then definitely keep on that journey and send those emails and send those CVs in, because I think that's the heart of the problem now. I don't think it's that there's any sort of discrimination going on. I think it's just we need more people to follow their dream and go for the jobs that perhaps they thought were out of reach before.
Yep.
Definitely don't think there's any there's no barrier. There should be no barrier to entry now, should there? That's the best thing. Well, talking of best thing, Camilla has asked, what's the best part of aerodynamics and why? I'm going to ask both of you this. Willem, to start with you.
So for me, it's the area in Formula One, say, but in most areas of motorsport, it's the one area of car performance where you can make the biggest difference. As a single human being, you can make a bigger difference in aerodynamics than almost any other area. Now, perhaps engines and so on, and it depends, but will change a little bit with different regulations. But for example, with the new regulations coming in for 2022, what's going to determine which team's best? Nearly 100% sure it's going to be the car with the best aerodynamics is going to be the winning car.
There we go. So put your applications in, because you could be part of that winning team. And Catherine, what about you? What is it about aerodynamics that you love? What's the best part?
So I will come from a slightly different angle. So for me, obviously, it's the wind tunnel. I love being in the tunnel. And for me, knowing that when I go into work and I press that button, the wind tunnel runs, the data comes through, that part goes to the track, that car wins. That's amazing. That's the best feeling in the world. And that's what I love about it.
And also, I think everybody in the team plays their role from every single job that's going on at Brackley. Obviously, I've been to that factory, and there's so many different people working across the team, but everyone's had a part to play in the car going fast. So it's a real team spirit. So if that again is something, aside from just loving engineering or aerodynamics, working as a team and it's so rewarding. I can imagine, Catherine, Sunday in, Sunday out for the last 7 years for you guys.
Yes.
Got it.
Bit of work to do at the moment.
It's great to watch, though. Not for Catherine, but for as let's say a semi-neutral spectator, I love a good fight, and you've got an incredibly close fight going on, and that for me makes it exciting.
Yeah. This is a great question. I'm going to ask. We've got so many good questions. Thank you so much for all of them. Going into the new regulations next year, do you think it'll be beneficial for teams to try and make the airflow coming off their cars as dirty as possible, make it harder for other cars to follow and overtake? I've got visions of banana skins and things like this, and wacky races. That's from Martha. Great question.
Great
Catherine,
question.
have you got any like rear gunners?
Well, I was thinking of putting some little daggers in the wheels.
You heard it here first.
I think the truth is, if a car does succeed in getting an advantage for themselves and as well generating more dirty air behind them, it will be harder for other cars to follow closely, and that will give them an advantage, especially if they're in front. If you're behind and someone else has done that, then you definitely don't want that. Yeah. But the rules have been devised to not have too dirty a wake, but yep, there's definitely an advantage. Now, it's quite hard in Formula One to design cars specifically to make it harder for people to follow, because we're only allowed to put one model in the wind tunnel at a time. We can't have one model following another. So it is quite hard. So the rule makers have tried quite hard for us not to do that. Yeah.
Talking of the wind tunnel again, Scarlett has asked another question, which she says is slightly off topic, but I feel I just want to know as well. In your presentation, Willem, there was an Audi DTM car, I think Scarlett has picked up on, and she just wants to know what part of the car was being tethered to the tunnel.
Aha! So we mount cars into the tunnel in 3 different ways. I think the Audi was mounted with cables, which is the most efficient way. It's the minimum aerodynamic interference, so strong cables mounting in towards the center at the front and coming out from something at the back of the car. So the ones in the front will take the drag force, they'll be in tension, being pulled back by the aerodynamic load on the car, and the ones at the back just keep the car stable. So that's one of the let's say aerodynamically the best, but you've got to make structural mounts you can bolt your cables to. Then we can do the same, use cables and pick up on, say if you have a road car with the jacking points underneath a road car, you can pick up on those jacking points, which are strong points underneath the car. But if you think about it, if you start going up and down big changes of ride height, you're wanting to stretch the cables or stretch the car. So those mounts on the jacking point pickups, where you'd jack the car up to change a tire, then we don't like them so much. And then one of the most common ways we actually mount is we take either the wheel nuts if it's a road car, or the central wheel nut if it's a racing car. We take those off, put a special nut on. We use the motorsport safety lock system, and then we bolt a bearing carrier to that, and then put arms onto the front wheels. And if you lock the steering with arms on the front wheels, the car will stay there rock solid, generally.
Eagle eye, Scarlett, like it.
Yeah, love it. Absolutely love it.
Again, even in just that answer, I'm hearing lots of different things are used in the wind tunnel, bearings and cables, and somebody's got to fit all of those things and create all those things. So again, going back to that sort of stand back, look at the huge picture, think of all the people who might be involved in building a wind tunnel or providing things for a wind tunnel. It's worth doing a Google, as simple as that, and just see what companies perhaps are involved. That might be an idea as well.
So if you're interested in wind tunnels, I have about a 44 minute video that you can access either via YouTube or something like that.
That's my Saturday night sorted, Willem, now. I've got Friday and Saturday sorted.
that explains how Formula One teams use their wind tunnels.
Fantastic. I do think it is that. I think people get very niche and focused in on, I want to work in Formula One, but you've almost got to just stand back and think who's involved, all of the amazing companies that are involved, down to like the little tiniest screw, and it could be you that makes that screw. So seriously, yeah, there's a lot of people involved in this amazing industry. So I can't believe it, but that has been an hour of both of your very precious time. I know, time flies when you're having fun. Thank you so much to everyone for your questions. There are a lot, but I do know that the wonderful people behind Girls on Track UK will be replying to you, and I'm sure you'll get a message of some sort, either thanking you for your question or hopefully maybe giving you a little bit of information. I've answered as many as we can get through, and a lot, there are some similar ones, so hopefully even if your question wasn't answered, perhaps you found some of the answers that were given helpful as well. So huge thanks to Catherine and Willem. Thank you so much for taking the time to talk to us this evening. Always amazing to expand one's horizon and to learn more about a subject. And hopefully you guys have inspired some of our wonderful viewers to send that email, send that CV and apply for that job. So thank you both very much. My thanks to Motorsport UK as well for making this webinar possible. And as I said at the beginning, we are recording. So the beauty of this Zoom webinar is that you can watch it back. You can share it with your friends if you're on the Facebook community page for Girls on Track UK. If you're not, then sign up. And the link is going to appear in the chat. There you go, just as if by magic. So if you'd like to be part of the community, then please do sign up. And also you can sign up for our mail outs as well. So that is a wonderful thing to be part of. Again, if friends of yours are interested and have been watching with you this evening, send the link to them as well. The more the merrier in this community, and I'm sure there are some wonderful webinars planned over the coming months and for the rest of the motorsport season. But for now, thank you all of you for your questions. Catherine and William, thank you so much, and everybody enjoy the British Grand Prix this weekend. It's going to be fabulous, especially with the new sprint qualifying and race. Lots to enjoy. So thank you to everybody. Have a wonderful evening, and hopefully we can all see each other in person sometime soon.
Thank you, everyone. Bye.
Bye.
Thank you so much.